Stoichiometry, Unit 7, and this is going to be number 1 on homework packet number 7 and number 1 on page 6. The multi-step problem, where we're going to take some methane, and that's like what's in our Bunsen burners, or that's the fuel for our Bunsen burners, runs through the Bunsen burners. We combine that with oxygen in the air, and it will form CO2, and it will give off water vapor. It will also give off a lot of heat energy. Definitely warm right there, exothermic reaction. And what we're going to do is we're going to start with 32 grams of methane and try to figure out how much oxygen was consumed, how much carbon dioxide was produced, and how much water was produced. And really, it's stoichiometry is just a method for figuring out amounts or quantities in equation. I think I'm going to turn this off before I before I combust myself. So I'll be a little bit careful with that. Drop the safety glasses, and let's get going with this problem. So I'm going to go to this right here and balance this equation. So if I have one CH4, I have one carbon, I'm going to have one CO2. And I have 4 hydrogens, so this should be a 2 right here. 2 times 2 would be 4 hydrogens. And what, 2 oxygens and 2 oxygens, that should balance like that. So it's 2 oxygens, and then 2 times 2 is 4 oxygens, and then 2 oxygens here, 2 oxygens here. So I have this balanced equation right here, and I'm given 32 grams of methane, so I might write that underneath right here, 32G underneath the methane, just to keep track of that. Okay, and I can also indicate that up here. This train is going to haul methane. That's just like a mole train we've always to work with. Okay, but I'm going to do this right here and say this is my starting point. Okay, in this question here, it says how many grams of oxygen are consumed. So I'm going to put a question mark here, and it's asking about grams. Well, I already have something for grams here, but this is a different substance, so it needs a different train. These 2 trains are identical, except they work the same way, just like the mole trains you always used, except now we're going to run 2 mole trains at once and unload from one to the other. So we're going to go from grams of CH4 to grams of O2. So we got to switch, got to jump trains at one point here in this problem. Now, if you look here, you can't go straight from grams CH4 to grams of O2 in one step, because our balanced equation does not say 1 gram of CH4 combines with 2 grams of O2 to form 1 gram of this and 2 grams of this. It does say 1 molecule of this combines with 2 molecules to form 1 molecule of 2 molecules, or 1 mole of molecules combines with 2 moles to form 1 mole and 2 moles. So this path does work, and this path would work, but there's really no reason to use it. But there is no path between grams in an equation, so we have to go a longer route. So my first step is going to be to convert grams of CH4 to moles of CH4. A rule is where I come from goes on the bottom, where I go to goes on top. So looking at this, if grams of CH4 is on the bottom, so I don't need this right now, and that is grams of CH4 is on the bottom. Okay, so I'm going to put that in here. And moles of CH4 is on the top. So I'm going from grams of CH4 to moles of CH4 in my first step. And I'm going to write moles, pretty small, CH4 right here. And sorry for the sloppiness. You'll be able to see this on the partial key too. So I went from grams to moles. Okay, and there are 16 grams in a mole of CH4, not 16 moles in a gram. So the 1 goes with the CH4, the 16 goes down here with this. I'm sorry, the 1 goes with the moles of CH4, the 16 goes with the grams of CH4. So essentially going from grams to moles, I divide. And if I did 32 divided by 16, I would be at 2 right here. But I'm just going to keep the chain going. Now I'm going to go from moles of CH4 to moles of O2. I'm going to put moles of CH4 on the bottom because that's what I know. So I'm going to go MOL, I know it's real small, of CH4 on the bottom. And moles of O2 on the top. I kind of got a question. Can I compare two reactants in an equation? It's kind of like making a sandwich and saying, oh, I have so many slices of bread. How many slices of cheese can I make? Of course you can. You can compare any two things, two reactants, two products, reactants and products, products and reactants. But where am I going to look to find this? This is a new step. Going from moles to moles, I look at the balanced equation. Look at this number, 1 mole of CH4. So I'm going to put a 1 here. And 2 moles of O2, so I'm going to put a 2 here. So it's that 1 to 2 ratio, or 1 on the bottom, 2 on the top, right there. So the 2 goes with the O2, the 1 goes with the CH4. What you come from and know goes on the bottom. So the 1 goes on the bottom. What you don't know, the 2 goes on the top. So that's telling me to double it. So I went from 2, 32 divided by 16 is 2, times 2 is 4. But that's still not done. Okay, I'm right here now. Now I got to get over to grams, but I'm working with O2 now. So I'm coming from moles. So moles goes on the bottom now. Moles of O2 goes on the bottom. And what's going to go on top? It's going to be the grams of O2. And I'll put that on top. And if the molar mass of oxygen is 16, the molar mass of O2 has got to be double that, or 32. Is it 32 moles in a gram, or grams in a mole? It's 32 grams in a mole. So 32 grams per 1 mole. Okay, I think that's taken me all the way here. Now I just take my numbers above the line you multiply, below the line you divide. 32 divided by 16 is 2, times 2 is 4, times 32 is 128. So I'm going to just kind of write my answer in here. I'm going to actually write it up here and say it is, maybe I'll use a different color here, 128 grams, or I might say if I rounded to 2 sig figs, I'd say 130 grams. And it is O2. So that is what I'm doing. I've got to do 3 steps. 32 grams divided by molar mass of 16 gives me the moles. Then I take my moles ratio from what I come from. The 1 goes on the bottom, the 2 goes on the top. So I ended up multiplying by 2 over 1. And then I multiply by the molar mass, but this time I go through the molar mass of oxygen, and this time I multiply it by 32. So that would be the answer to part B. All right, I'm going to look at part C and D here, but I'm going to go to a different page. I know you have it all lined up here, but I think that'll make it easier to see. I'm going to clear this out and do part B, which is also on page 6. And let's go here and take a look. Okay, just kind of made a new mole train so we could see it. And I'm hoping to make this bigger so we can see this. And, okay, I'm going to lose this. Oh, I know what's happening. It's hiding my little spot here. Okay, that's better. Okay, I think I'm still sharing. I hope so. I think I am. So now we're a little bit more organized and a little bit bigger so we can see this. Sorry about the intermission. And what this time it says, how many grams of CO2 form? Assume we're starting with 32 grams of CH4 like before. So the CH4 is going to be the same. We're starting with 32 grams here. But now this time, instead of going to grams of O2, we're going to go to grams of CO2. There's no path here. It looks like we're going to do the same thing, except just with a different substance. Can you compare a reactant and a product? So it looks like we're comparing what? CH4 to CO2. Yes, just like you can compare a number of pieces of bread to how many sandwiches are formed. You can compare reactants to reactants, products to products, or products to reactants. Any two things in a balanced equation. So I'm going to do this first step the same thing. Grams divided by molar mass gives me the moles of CH4. So that's the same. The next step is to go from moles of CH4, so I put that on the bottom, to moles of CO2, so I put that on the top. Where do I look? I look at the balanced equation. This is an easy one because they're both 1, so essentially it's times 1 over 1, which is the same thing. But I like to show that step to make sure that you're aware of that. And the last step is to go from moles to grams. And what do? We multiply by the molar mass, this time of CO2. So 1 mole of CO2, I'm coming from moles of CO2, so that goes on the bottom. We go to the grams. The molar mass of CO2 is 44. So I'm going to put 44 in here, right here, and here. And what do? 32 divided by 16, just like in the other one. This time times 1 over 1, because that's your mole ratio. And then the last step is to multiply by the molar mass of CO2, which is 44. 32 times 1 over 1 is still 32. I'm sorry, 32 divided by 16 is 2. Times 1 over 1 is still 2. Times 44 is 88. And it should be 88 grams of CO2. I think I'll just leave that at 88 grams of the CO2. Okay, let's do one more from this page, and I'm going to clear that one out. And these are all kind of lined up one after another. So let's look at this, and got its own new mole train for this part, but let's take a look. This one is given that we have grams of CH4, and it says how many moles of water form. And because this is all part of the same problem, we're going to assume we're starting still at 32 grams of CH4. So we're still starting in the same place. Now we're switching it out, bringing water in here. And we're not asked for grams, we're only asked for moles, so we don't have to go as far. Well, just like before, 32 grams times 1 mole over 16 grams gets me to moles. Then the next step is to go through the mole ratio. What am I comparing? I'm comparing moles of CH4, which I know, to moles of H2O, which I'm trying to find out. I have 1 mole of CH4 from the balanced equation here. I have 2 moles of H2O from the balanced equation. So I put that 2 there. And then I'm done, okay? So, well, I better calculate it. 32 divided by 16 is 2, times 2 is 4. So my answer is going to be what? I guess I'll say 4.0 to keep up with my sig figs. So I'll do that there. Let's try that again. 4.0, whoops, moles of H2O right there. All right, so that is question 1. There'll be another video with question 6 just to give you another sample with this. Thank you.